This is one of my favorite movie clips of all time. The teacher goes through a process of describing positive and negative numbers using sand to see how we arrive at zero when we do the opposites of positives and negatives, like +1, -1.
It's Frank Garcia. But when I say Garcia, you answer, okay? Are your friends auditing?
I audited them to come with me.
Tough guys.
I'm El Cyclone from Bolivia. One-man gang. This is my domain.
He's tougher.
Don't give me no gas. I'll jump on your face, tattoo your chromosomes. This is basic math, but basic math is too easy for you burros. So I'm gonna teach you algebra because I'm the champ. And if the only thing you know how to do is add and subtract, you'll only be prepared to do one thing: pump gas.
Hey, ripping off a gas station better than working in what, you know?
Orale. Orale. I'm a tough guy.
I don't know
Tough
what
guys
orale
don't do
means.
math. Tough guys deep fried chicken for a living. So orale. You want a wing or a leg, man?
Oh, wait.
Whoever heard of negative and positive numbers? Anybody?
Yeah, negative numbers are like unemployment. 10 million people out of work, that's a negative number.
We're gonna need a lot of Kleenexes. There's gonna be a lot of bloodshed. You ever been to the beach?
Yeah.
You ever play with the sand?
Yup.
Finger man. Come on, finger man. You ever dig a hole? The sand that comes out of the hole, that's a positive. The hole is a negative. That's it. Simple. Anybody can do. -2 + 2 equals. Nethead. Orale. Answer it. Come on, you know the answer. -2 + 2 fill the hole. If I had that on my hands, I wouldn't raise it either. Orale. Come on, a -2 + 2 equals. Anybody can do it. Fill the hole. -2 + 2 equals.
Get this all the time.
Just fill the hole.
No one wants to answer.
Do it.
So easy.
These burros laugh at you. -2 + 2 equals.
Just say 0.
Break your neck like a toothpick.
Oh, he's gonna break his neck.
Orale. 0.
0.
0. You're right. Simple. That's it. -2 + 2 equals 0. You just fill the hole. Did you know that neither the Greeks nor the Romans were capable of using the concept of 0? It was your ancestors, the Mayas, who first contemplated the 0, the absence of value.
Absence of
True story.
value.
You
Nothing's
burros have
there.
math in your blood.
Hey, Kimo sabe todo, the man knows everything. Órale. Kimo sabe.
Orale. Okay. Parentheses means multiply. Every time
You
you
knew
see
that.
this, you multiply. A negative times a negative equals a positive.
This is the
A
future.
negative times a negative equals a positive. Say it. A
Negative times a negative equals a positive.
Say it.
A negative times a negative equals a positive. You don't need to know this yet, but you will.
A negative times a negative equals a
You
positive.
should be saying it.
Negative times a
Get it in your
negative
brain
equals a
now.
positive. I can't hear you. A negative times a negative equals
One-step equations, addition and subtraction. Solving an equation is like balancing a scale. Both sides must remain equal. So like right here, we can think of our middle of our scale as our equal sign with some object on the left. And now if all these objects were there, our scale would be weighed down and our other side would be up. But in order for an equation to exist and be true, both sides need to be equal.
So what does this mean? What are those two little lines in the middle trying to tell me? Well, historically people have thought about equations like balance scales. You can see one over here. When the two sides are the same, it's green. When weight is added to one of the platforms, the scale turns red, indicating that the equation is unbalanced. When you remove that weight, it goes back to being in equilibrium. So let's take a look back at our equation over here. 3 + 3 = 6. The first part of that equation is 3 + 3. So let's go ahead and model that on our scale. You can see the scales become unbalanced. We have to finish the equation to make it balance. On the right-hand side, we have 6. So let's go ahead and place a 6 on the right-hand side of our scale. And you can see they balance each other out. 3 and 3 is 6, they're the same. But we're actually saying something a bit bigger here. See, that 6 on the right-hand side, that's not really a 6. That 6 is actually 6 little 1 blocks. And the 3 blocks on the left, Well, each of those blocks is actually worth 3 1 blocks. So instead of thinking about it as adding 2 3s and getting a 6, you can think of it as combining 2 sets of 1s. So what this equation is really telling you is that 3 1s plus 3 1s equals 6 1s. This may seem kind of trivial, but remembering integers as groups of 1s is really helpful for algebra. And that is the mystery of x. We're trying to find out how many 1s are inside that x because it's different in every problem. It might be 1 in one problem, the next problem x might have 3 1s inside of it, and in the next problem x might have, well, a bunch of 1s in it. So that's sort of what we're trying to figure out, how many 1s are in x. So let's look at this.
All right, so basically what he's explaining is that we want our equation to be balanced. So we don't want one side to be more than the other side. So if I want to make this balanced, I have to have the same numbers on each side, whatever they be, whether it's 3 plus 3, which would be 6, or if it was 6 equals 6, right? Or if it was 2 plus 2 equals 4, or 1 plus 1 plus 1 plus 1, right, would equal 4. Sometimes we have an expression like this, where we have an unknown number, which would be represented as the variable. But let's see how this works with a scale.
Really easy algebra equation. You might be able to do this in your head. But let's examine some of the concepts at play here. We'll start by modeling on the scale. We have 1x and 3 1s on one side, and on the other side, we have 7 1s. So to solve this, what I might do is try taking 1 from each side at a time. I'll take 1 from both sides, and it's still in balance. I take the same thing from both sides again, it's still in balance. I'll try that one more time, and I'm still in balance. And look what the scale is telling us. 1x is 4 1s. X equals 4. And how do we get that? Well, we subtracted 3 from both sides. Let's take a look at the numbers. See, what we did was we subtracted 3 from both sides, effectively canceling out the plus 3 on the left, and that left us with x equals 4. So algebra is sort of the process of removing clutter from the side with x. I want to make this equation tell me what x equals, and the way I do that is by removing the plus 3 by subtracting 3 from both sides. This is the basic process of solving algebraic equations, getting x isolated on one side. Okay, here's another equation.
All right, one thing he said there that was important was that you're getting x isolated on one side. But looking at this example picture right here, we can look at something a little like this balance. So on the left side here, we have 3 positives, right? 1 plus 1 plus 1, there's 3. On the right side here, we have 7. Now, as you can see, my balance is way down on the right side. Well, I need this thing to be equal, and I don't know what number is missing here. So, on my balance, I can simply just keep going by adding 1s until it reaches balance again. So I could go 1, 2, 3, 4. I tapped it 4 times. That means my number that's missing must be 4. So when we're solving one-step equations, the variable must be alone or isolated. Isolated meaning that there's nothing else there. You're completely by yourself on one side of the equation. Isolate the variable by using inverse or opposite operations. And if you were wondering what that is, you just have to memorize what the opposite operations are. So for example, if your operation was addition, you'd have to use its inverse, its opposite, subtraction. And then vice versa. If your operation was subtraction, you'd have to use its opposite, which is addition. So 3, the equation must remain balanced. And then you can always check your solution. And we can also use something called algebra tiles to represent an equation.
Solving equations. We're going to stick with one-step equations, but as a reminder, our goal for this standard is to get the variable on a side by itself so that we can determine its value. While we're doing this, it's also important to remember the golden rule of solving equations is that we must do the same thing to both sides. So if you do it to one side of the equation, you have to do it to the other side of the equation as well. Today we're going to...
That's a big rule right there, okay? What you do to one side of the equation, you have to do to the other side of the equation. All right? That is your golden rule. So make sure that you remember that always.
That we must do the same thing to both sides. So if you do it to one side of the equation, you have to do it to the other side of the equation as well. Today we're going to use some hands-on manipulatives to help us visualize what's actually occurring in our equations while we're solving. But before we can start, we need to determine what each one represents. That way we understand what's actually occurring in our equations. So this green bar up at the top, this is going to be mostly referred to as x, a positive x. It could be any variable that we don't know the value of. The red bar right below it is what we'll refer to as a negative x. And then this yellow is just going to represent 1, positive 1, and the red below it, the little red, is going to represent a negative 1. The last thing we have to make sure we understand before we start with the strategy is something called a zero pair. And a zero pair occurs when we have a positive and a negative together. Because we have a positive one and a negative one, when we add them together, it ends up equaling 0, and that's why we call it a zero pair. The first equation we're going to model with our algebra tiles today is the equation x plus 5 equals 7. When we use algebra tiles, we like to use this t-chart because it helps us keep the different parts of the equation separate, and that way we can make sure that we're doing the same thing to both sides and following that golden rule. So again, we're going to use this long green bar to represent our x, and then we're going to use 5 yellow tiles to represent the plus 5. On the right side of our equation, we have 7, so we need 7 yellow tiles to represent that. So again, when we're solving equations, our goal is to try and get that variable on a side by itself, meaning that we want the value of the left side of this equation to be equal to just an x. But right now it's equal to an x plus 5. This is where our idea of zero pairs comes in. By creating zero pairs, I can eliminate that value of 5 so that this side only has a value of x. So I'm going to take red tiles and match them up with each of those yellow tiles on the left side. So now on the left side of my equation, all of these zero pairs cancel each other out, and we're left with just a value of x. But that golden rule says whatever I do to the left side of the equation, I must do to the right side. So that means I must now add 5 red tiles to the right side of the equation. Now that I've added 5 red tiles to the right side of my equation, I can see that all of these ones have created zero pairs and are going to cancel each other out, but these two are left by themselves. This means if I clear out all of the zero pairs from the left side and the right side of my equation, I can easily see that x is equal to a positive 2.
All right, a little bit of new information for you right there. Now, here's what she was talking about with the algebra tiles. When she's talking about algebra tiles, she's talking about what's on the left side of your paper right here, right in the key. All right? In this case, they're going to represent x with this rectangle white object, and they're going to represent a positive with one white square and a negative with a gray square. Okay? So in order for us to write this equation, I just have to see what's there. So I have an x. So in my equation, I have x. Then I have 4 positives. So I have a plus 4. What is it going to be equal to? It's going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right there I have my equation. I found an x in there. On the left side I found 4 positives there. And on the right side I had 10 positives. Now when I want to do a solution to this problem, it could look something like this with the algebra tiles. If I wanted to find it on my worksheet, I could simply have my gray tiles match up to make zero pairs. But remember, the golden rule of solving any equation is that we do what we do to one side, we got to do to the other side. So if I just had 4 negatives here and they're going to be gone, I got to make sure that I have one paired up for each one on the other side. So I'm going to pair these up, and then when I pair these up, they go away. So now I have I have 2 done, and I'm going to need 2 more on the other side. So I've done the same thing to both sides. I've created zero pairs here. So again, the object was to get x by itself. That's what they say when they want to isolate the variable, right? So I want to isolate the variable. So now that I've paired them up, they're essentially going to be going away. So they are actually going to be disappearing from the equation. They will be gone. And the same thing could be said about the other side. So now that it's gone, these will also be gone, leaving only x equals how many? 1, 2, 3, 4, 5, 6. So now I know my solution is 6. So let's try this number 1 right down here. I'm going to help you with it. All right. Right here we have write and solve the equation represented below. So if I have to represent this equation, it would be done a lot like this, where I take my tiles and I have x plus 2 equals 6. So I can easily represent that situation with algebra tiles. Now, my equation is going to be a little bit different. So I do know my equation is just by looking at the tiles. So I'm going to demonstrate that for you real quick. So we got x plus 2 equals 6. Now, when I want to solve an equation using the algebra tiles, I want to isolate this variable. I want to do the opposite of addition. So what is the opposite of addition? The opposite of addition is subtraction. And I want to get to 0 by subtracting 2. And what I do to one side, I got to do to the other side. Very important. Okay? Now, what does that look like with tiles? Well, if I want to get rid of these tiles, I would pair them up with a negative. Now these might be going away, right? And what I did to this side, I have to do to the other side. Now all these tiles that are paired up right here, they'll be gone. So I'm going to remove them from my mat to show you that it's not there anymore. So this little process I just did there is a lot like getting rid of everything that's on that screen right there. That's going to be absolutely gone. We've just gotten rid of it. It is not here anymore. So everything right there is now gone. Now what I did to one side, I did to the other side. So basically I have 6 minus 2. So I can easily just take away my 0 pairs. And I should only have 4 ones left, which is a pretty easy math problem. So now I know what x does equal. X brings down, and it equals 4. So when I write my equation on my paper, I can write x plus 2 equals 6. Now my solution for that would just be that x equals 4. Alright, so using the information that we've given you, you just have to write an equation for this. Okay? And if you wanted to use this program right here, I am going to post this for you with a little link. Okay? And just to model it for you, verbally. Alright? And I'm going to want you to write in the answer. We have how many ones on the left side? I have 4 ones. And then I have an x on the right side. And just to go to show you real quick how you use this, all right, you'd go into there, you'd find your grade level, which is 6, okay? And then you could find your backgrounds, and in this case, this background is the equations chart. And more importantly, the manipulatives that you're going to be using are called algebra tiles. So, if I have in number 2 here, I'm going to represent that just as it is. So it looks like we have 4 ones on the left, and then on the right, I'm only going to have 1 1 and then an x. So if I have 1 1 here, I make sure I use this green bar, which is going to represent x. So now I do know my equation. Just by looking at it, if I want to know my equation, I can just look right here and see that on this side, I have x plus 1 with the equal sign in the middle to 4. Now, for example, you could write this either way. It doesn't matter which way you write it. You could write it as x plus 1 equals 4, and it would be the same thing. As we move to the next part of this, it's very, very, very important to know that when you are solving equations, one-step equations, two-step equations, whatever it is, you will always begin on the side with the variable. This is a very common mistake. So, for example, in the one you're going to be doing for me, for number 4 here, which side would I be starting on, the left or the right? Well, which side is the variable on? It's on the left. So you would be needing to start over here. So here's another example, right? I did some of the work here for you, but I'm going to show you right here on this board. So my problem is x minus 6 equals 12. So which side am I going to be starting on? Well, which side has the variable on it? The left side. What's the opposite of subtraction? You guessed it, addition. So I want to get the variable by itself. How can I do that? By adding 6 and getting rid of it to make 0. So let's get that x by itself by adding the opposite that's there. But very important, what I did to one side, I got to do to the other side. So I need to add 6 to the other side. Now essentially, what I've done now is I've gotten rid of everything that's right there. And x is now by itself. And it's going to be equal to 12 plus 6, which of course is 18. Now, if you wanted to check your answer, you could by plugging in 18 for x. So now I know that x is equal to 18. So what I can do is I can plug in 18 by substituting it right here. So what is 18 minus 6? It's 12. And is it equal to the other side? It sure is. All right, here's another one, number 5. I'll show you how we do this one. So we have the expression 3 plus x equals 7. So on the left of my equal sign, I have 3 plus x equals 7. Now, I want to get the variable by itself. Now, what operation is being done? Well, this is actually a positive x. This term is positive. Now, there is a little invisible plus sign in front of that 3, but we never really write a plus sign in front of another number like that. We just assume that it's there. Okay, so we'll just know that this is positive 3. So, I want to get the variable by itself. What side is the variable on? The left. It's over here, so let's start there. I have a positive 3, so I want to do the opposite of what a positive is. So, I want to do a negative. And what I did to one side, I need to do to the other side. So on the other side, I need to subtract 3. Now essentially, the left side that was positive 3 and negative 3 is going to go away. X comes down, and it's going to be equal to whatever 7 take away 3 is, which is 4. So let's take a look at number 7. For number 7, it looks a little backwards. My variable is on the right, and what it's equal to is on the left. So I know that this side is 17, which means that this side must be 17 if I want it to be balanced. So my equation, is actually 17 equals x plus 4. And I want to start with the side that has the variable on it, which is the right side this time. And I want to get the x, the variable, isolated. I want to get it alone. So what's the opposite of addition? It's going to be subtraction. So I'm going to take 4 away and then do it to the other side as well. Because what I do to one side, I have to do to the other side. Once I do that, I'm going to have 17 take away 4 on the left side. And then these 4s, they go away. Now x is left all by itself. And what's 17 minus 4? You guessed it. 13, right. So now I have 13. X equals 13. So remember, when we have something like a positive and a negative, it gets crossed out because it's now gone. Okay, now it's no more. There's no more there at all. Now, the other side, we did it. What did we say that it was? We said that it was 13. So x is actually the unknown number 13. Now, if I wanted to check my work, I would just say that 13 is x. And replace it. So now I have 13 plus 4. And as long as both of your sides are balanced, then you know. So if I have 13 plus 4, I should get 17. That means both sides are 17. So I'm good to go. As long as both sides are 17, then I'm ready. So as long as both sides are good, you could say either way. You could say 13 plus 4 is equal to 17. But really, 13 plus 4 is 17. And now my equation is true. Both are balanced. So let's take a look at number 10. In number 10, we have 32 on the left side of the equation. And on the right side of the equation, we have x. Take away 8. So that means I'm going to be starting on the right side of my equation because that's where the variable is. So I want to start undoing my equation with the side that has the variable. This side of the right side here has a minus sign. So I want to do its opposite. So what's the opposite of subtraction? The opposite of subtraction is addition. Now remember, what I did to one side, I also have to do to the other side to make it balanced. So what happens to this minus 8 plus 8? It ends up going away. And all that is left is x. So in essence, it's now been erased. It's disappeared. With the only thing left as x. Now on the other side, we have to find out what x equals. Well, what's 32 plus 8? That's 40. So I know that x equals 40. Now if I know what x is, I can substitute it in. When I substitute it in, I could literally just replace it there. So what's 40 take away 8? 40 take away 8 should give me 32. Now I have a balanced equation. So I know that this is correct.